All right, ladies and gentlemen, these notes should be a huge review for you, to the point that I'm honestly going to skip over quite a few examples, primarily to save time, but also because I'm going to keep these short and sweet, I hope, because like I said, it should be just a huge review for you. So today we're going to talk about this idea of evaluating functions. So the first thing we need to talk about, what is function notation? Okay, function notation is an alternate way to express y. So instead of y equals, now we're giving a name to our function and we're going to discuss or write about it using fewer symbols. So, generally speaking, y equals f of x. Now, this is very generally speaking, but 9 times out of 10, that's exactly how you're going to see it. Y equals f of x. And if you notice the way I'm saying it, it's red f of x, which means y is a function of x. Okay, so what this actually does for us is that it shows that y is dependent on x. It shows that everything is dependent on x, where x, x is independent, y is dependent. Okay? And so, oops, here I am just scribbling things all over the place. It's fine. Whoa. So, here's a note for us down here. For functions, the input or the domain value is going to go inside the equation or the parentheses. Okay, so if the domain is inside the parentheses, that means the output or the y values are outside the equation. So they're what the equation equals. Okay, so that's function notation in a nutshell. All right. And then we have this fun stuff. What does it mean to evaluate a function? It means to find the value of, to find the value of when given the input by plugging in and simplifying to get it down to a one-number answer. Okay, so a special little note here for us. When we plug things in, you should plug in using parentheses. Okay, so let's go ahead and look at this. Guided practice. Let's go ahead and look at these. All right, if the function f is given by f is equal to -2, 0, 3, -1, express each ordered pair using function notation. So we know that function notation is, function notation is f of x equals y. Okay, so we know that f of x equals y. So what I'm going to do for this first set of points, we know this is x, this is y, so f of -2 equals 0. So for the second one, this is x, this is y, f of 3 equals -1. And yes, those are our answers. Okay, so f of 2 equals 0, f of 3, negative 1. Those are our two answers, and we're done with that entire problem. Okay? Looking at number 2, it says if f of 7 equals 5, then what is the ordered pair? This is x, this is y, so the ordered pair is 7, 5. Okay. If g of negative 1 equals 4, then what ordered pair is in g? So guys, instead of f, they use g this time, which is totally okay. We can have that happen. But this is x, this is y. So our ordered pair, negative 1, 4. Okay. Hopefully that seems pretty straightforward, because it is, where we just plug things in and we call it good. Okay, so we're gonna finish this example for the day, and this is just our part 1. All right. So let's look at number 4. If f of x equals 4x minus 1, and g of x equals 3x squared plus 2x minus 1, find each of the following. So this is important, and the reason it's important is we need to look at what letter we're talking about, because we don't want to plug things in randomly to the wrong equation. So A, we're using F, B, we're using G, F, G. Oh, okay, so there are some G's in there. All right. So looking at A, it says f of 2. This means that x equals 2. Okay? And this right here. And we're plugging it into f. So everywhere there is an x in f of x, we're going to plug in 2. So it's literally like substituting the 2 in for the x. We use parentheses. So f of 2 is 7, because 4 times 2 is 8. 8 minus 1, 7. Cool beans. For B, we have g of negative 2, so in g, we're going to plug in negative 2 everywhere there's an x, so g of negative 2 is equal to 3 negative 2 squared plus 2 negative 2 minus 1. Oops, sorry, C. So we have 3 times 4 plus 2 negative 2 minus 1. So we get 12 minus 4 minus 1. So g of negative 2 is equal to 7. Okay, so f, we know that this, a minus 2, that's taking the place of x. Okay, so we have f of a minus 2 equals 4 a minus 2 minus 1. So in order to solve this down as simple as possible, we're actually going to distribute that 4, and then we'll combine like terms. So we have 4a minus 8 minus 1. So when we I can't do this. 4a minus 9. And I can't simplify any farther, so that's my final answer. It would help if I could draw straight lines, you know? But alas, I can't be perfect. All right, these next two questions are actually pretty simple, and I say that because we actually already know, we've already done almost all the work. So we have f of 2 plus g of negative 2. Well, it just so happens that we actually already solved for both of these things. Okay, so we know that f of 2 is 7, plus g of negative 2 is also 7, which means our answer is 14. Ooh. Okay. So then for D, oh no, what just happened? I don't even know what happened. Whoa, that's so weird. Why is it moving? Can I make it stop? Okay. Alright, that's so weird, guys. I'm sorry. It takes little things to make me happy and confuse me, obviously. So now we're over here at D. We already know f of 2, like we said before. F of 2 is just 7. Minus g of negative 2, which is also 7, which means our answer here is 0. So, ladies and gentlemen, that was part 1. Go ahead and do part 1 questions, okay? Let me know if you have any answer or questions, okay?